All right. Very good.
Hello.
No.
Hello. Now is it on? Oh, there we go. All right. Hello. Welcome to Is There Modern Scientific Evidence for the Existence of God? We've got Dr. Michael Strauss here tonight to share with us. And just so you know a little bit, my name is Kent. I'll be your MC for the evening. And just so you know a little bit about what our plan is for tonight, Dr. Strauss will speak for about 45 minutes on modern scientific evidence for the existence of God, and then there'll be a Q&A time after that. But just before that Q&A time, we'll have a chance for you to, we'll have a couple of announcements, and then we'll have a chance for you to fill out a comment card. But we also want to let you know, for that Q&A time, we're letting you know that now so you can be able to, if you have questions, you can jot those down. There'll be a QR code that you can scan as soon as he's done with his talk. You'll be able to do that, or there'll also be a mic rotating around the room, and you'll be able to ask questions live that way. We'll just rotate back and forth between the two. So if you want to remain anonymous or whatever, you do it that way, or just do the microphone. So, Dr. Michael Strauss is a David Ross Boyd Professor of Physics at the University of Oklahoma in Norman, Oklahoma. He conducts research in experimental elementary particle physics, currently at CERN in Geneva, Switzerland, and he just got back from there, being there for a week, just about 10 days ago or so, where he studies the fundamental particles and forces of the universe. His previous research was done at the Stanford Linear Accelerator Center and at the Fermi National Laboratory. Dr. Strauss earned his Bachelor of Science degree in Physical Science from Biola University and his PhD in Elementary Particle Physics from the University of California at Los Angeles. He's spoken about the intersection of science and Christianity at universities, schools, and churches throughout the world. He's the author of the book, The Creator Revealed. A physicist examines the Big Bang and the Bible, and one of the general editors of Zondervan's Dictionary of Christianity and Science. He's recently a co-recipient of the 2024 Texas A&M Trotter Prize for his work in illuminating the mechanisms and wonder of nature, particularly relating to the connection between science and religion. He's been married for the last 34 years and has 2 grown children. So without further ado, Dr. Michael Strauss.
Thanks, Ken. It's good to be here. Go Big Red, of course. So yeah, let's get that out of the way first. All right. As was said in the introduction, I am an experimental particle physicist, and I know you really came here to hear about my research, so we'll start with that. And so this will be on the quiz at the end. Make sure you take good notes. This is what I study. We know the universe is made of atoms, and atoms have at their core a nucleus. Nucleus are made of neutrons and protons, and neutrons and protons are made of quarks. Most people have heard of quarks by now. They were discovered in 1974. I have spent most of my career studying how quarks go together inside neutrons and protons. I was wondering, does anybody know what quarks are made of? No, neither do I. We could win a Nobel Prize if you did, so I was just checking. All right. I do my research at a laboratory called CERN. It's near Geneva, Switzerland, and we want to understand the structure of nature at CERN, so what do we do to understand how the universe is put together? Well, suppose you wanted to know how a car is put together, like, you know, your parents' BMW or something, but you didn't have any tools to take the car apart, nothing to look inside and see how it works. What would you do? Well, how would you get the car apart without any tools? Well, if you're a particle physicist, you get the car going really, really fast, and you smash it against another car going really, really fast, and you see what comes out. You know, I say do this with your parents' car, not with your own car, of course. And so this is what we do, not with cars, but with protons. There is a ring, a tunnel that's about 17 miles around and about 100 meters underground. You can see it in the picture here. Let's see. So here's the Geneva airport. This is the city of Geneva, just to give you a scale. And this tunnel runs underneath the farms and villages and towns of France and Switzerland. The dotted line is the border between the two. And in the tunnel, we have these big superconducting magnets. We accelerate protons to nearly the speed of light. Here is one of the magnets taken apart, so this pipe would carry protons one way, this pipe would carry protons the other way, and then every once in a while we bring the protons together, and for about 24 hours a day, 6 months of the year, 40 million times a second, the protons smash together. And we built a big detector, which is like a camera, to see what happens when the protons collide. This is a picture of the detector I work at called the Atlas detector. This is actually the world's largest man-made cavern that this detector is in. So protons come whipping around this way, they smash in the middle of the detector. It's huge. To give you some idea of the scale, here are some people standing beside this thing. It's about half the length of a football field. We know what football fields are in Nebraska, and it's about 10 stories high or something. And so 40 million times a second, the protons collide here. The computer takes pictures that look something like this. This is not a spirograph drawing, for those who are old and know what that is. This is a picture of the particles that were created when the protons collided. And from this we understand, or try to understand, the structure of the universe. If you follow science news, this is one of the 2 experiments that discovered the Higgs boson in 2012. Peter Higgs predicted this in the 1960s. It was discovered in 2012. There were 7,000 physicists involved in discovering the Higgs boson. So I will take credit for 1/7,000th of the discovery of the Higgs boson, one of the 7,000 names. So that's what I do in my professional life. It's fun. We play with big toys, expensive big toys, which is always fun. Tonight I want to ask a different question, not just about particle physics, but we can talk more about that. And I want to ask this question: what does science have to say about God and the place of humans in the universe? Is there anything from science that can tell us anything about God? And you often hear the story of science that runs something like this. Once upon a time, humans used to think they were important and that there was a God, and they were naive, and then science came along. First of all, Copernicus comes along and he tells us that we're not the center of the universe, so that seemed to make us less important. And then Newton came along and said that the universe is run by laws of physics, mechanistic laws. And if the laws run the universe, we don't need any God because the laws work, although Newton believed in God. And then Darwin came along and said, humans are nothing special, we're just the product of random mutation and natural selection and basically a big accident. And this is the story that we're often told that science has said about the place of humans and the place of God in the universe. There's a couple problems with this story when it's told that way. The first problem is it's simply wrong. It is a false story that's based on myth, basically. It is true that before Copernicus, humans used to think that the earth was the center of the universe, but that was not a good thing. So here's a picture that comes from Dante's Divine Comedy, and here's the earth, the center of the universe, but in the center of the earth is hell itself. So it's the closer you get to the center, the worse things are. And the earth was actually considered like the garbage heap of the universe because everything would fall toward the earth, all the garbage of the universe. So when Copernicus came along and said that the earth was one of these planets, these perfect planets that at that time they thought went in perfect spherical orbits or whatever, circular orbits, he actually elevated the place of humans. Instead of the earth being the garbage heap of the universe with hell in the middle, we were now one of these exalted planets. So Copernicus didn't lower the place of humans, but he elevated the place of humans. But another problem with this story is it's old. It has nothing to do with modern science, right? I mean, Darwin wrote Origin of the Species in the mid-19th century. And the question I want to ask is, what has modern science told us about humanity and the place of God in the universe? Is there any evidence from science for the significance of humans and for God? And so I want to talk about 4 different things tonight. The origin of the universe, the design of the universe, something called the rare earth hypothesis, and then finally the fact that mathematics describes the universe. I'm not going to present proof for God. You can't prove God from science. In fact, you can't prove anything in science. You can only disprove things. The only things you can prove are in logic and mathematics. Everything else you just give probabilities to. So I'm going to present evidence that I think gives strong evidence that there is a God, a creator of the universe, a designer, and then you can decide how strong that evidence is. And at the end there'll be time for questions. So all questions are great. If we want to try to find the truth about anything, We need to be able to ask tough questions about those things. All right, so let's start with the origin of the universe. Most of you know what science has said about the origin of the universe, what we've developed over the last 100 years or so. And what does modern scientific cosmology says? It's led to the idea that the universe seemed to have a beginning about 14 billion years ago. The word Big Bang is often associated with this, although the Big Bang has multiple meanings. One meaning of it would be the very beginning of the universe, but most scientists don't use it in that way anymore. They use it to mean something shortly after the beginning, when we kind of understand the physics that's involved, maybe about a trillionth of a second after the beginning. I'm going to use it tonight in its original meaning, which is the very origin or the beginning of the universe. And what it seems to appear is that the universe came into existence about 14 billion years ago, and that matter, energy, space, and time actually came into existence. Now, if we lived 100 years ago, first of all, we'd be really old now, but beyond that, we would have no idea about the origin of the universe. But in 1929, Edwin Hubble discovered that the universe was expanding. He measured the galaxies, and he saw that the further a galaxy was from us, the faster it was moving away from us, and the closer it was to us, the slower it was moving away from us, but it was still moving away from us. So here's a picture of raisin bread, and if you put raisin bread in the oven, all the raisins get farther apart because the raisin bread is expanding. And the raisins that are close get farther apart slower than the raisins that are far away. So you could think of the universe as this raisin bread, and this is what Hubble discovered, that it was expanding. Well, you know, if it's expanding, then that has an implication. And the implication is that there might have been an origin. It must have started to expand at one time if it's expanding now. And scientists have never liked the idea that the universe might have had an origin. In fact, 2 years after Hubble's discovery, Arthur Eddington wrote this. He was a cosmologist in 1931 who wrote, "Philosophically, the notion of a beginning of the present order of nature is repugnant. I should like to find a genuine loophole." So why is it repugnant that the universe might have had a beginning? Well, if the universe might have had a beginning, it might have had a beginner, and that is a repugnant idea. So scientists don't like the idea of a Big Bang beginning. But yet we've all accepted it. Why? Because the evidence is overwhelming. And there's primarily 3 pieces of evidence that tell us that the universe had a beginning. The first piece is that the universe is expanding. If it's expanding now, it must have started to expand. The second is the amount of hydrogen and helium and other light elements. So about 3 minutes after the Big Bang, you've all been to chemistry class, and there's this periodic table hanging there. About 3 minutes after the Big Bang, hydrogen and helium were created from the early elements. That's all the periodic table that was created during the Big Bang. And yet we can predict exactly how much hydrogen and helium we should see if the universe started 14 billion years ago. And our predictions agree with what we actually see to about 1 part in 10,000. So it's a great theory if you can make predictions that precisely. The other evidence that convinces us that the universe had this beginning is the temperature of the universe. So originally, the universe was very hot and dense. If you take the whole universe you can see, shortly after the Big Bang, that was condensed into the size of about a cantaloupe and extremely hot. And since then, the universe has been expanding and cooling, but we should still see some residual heat from the universe 14 billion years ago if it started with a hot Big Bang. And we see that. It's called the cosmic microwave background radiation. And again, the temperature profile that we see in the universe is exactly what we would expect if the universe had this Big Bang beginning. The theory agrees with the observations to about 1 part in 10,000. So everything we observe seems to indicate that the universe had a beginning. But it's not just what we observe, it's also what we can calculate with theoretical calculations. In 1915, Albert Einstein came up with what we call the general theory of relativity. It describes how gravity works. And in that theory, the equations of his theory actually predicted that the universe should be expanding. Now, that was before Edwin Hubble made his discovery, so Einstein didn't like that idea. He knew that the universe, if the universe is expanding, it might have a beginning. He didn't like the idea. It didn't make any sense. So he added a fudge factor to his equations called a cosmological constant. When Hubble discovered that the universe was expanding, Einstein later wrote that adding that fudge factor was the worst mistake of his professional life. He should have realized that the universe was expanding. His equations predicted it. In 1973, Stephen Hawking, Roger Penrose, and George Ellis expanded Einstein's theory of relativity and realized that it actually predicted that time had a beginning. Now, I have no idea what that means. I'm pretty trapped in time, but it seems to be that the equations tell us that time itself had a beginning. And then in 2023, three more physicists, Arvind Borde, Alan Guth, and Alexander Vilenkin, developed what we now call the BGV theorem, Borde, Guth, and Vilenkin, and it showed that any universe that is expanding on average must have had a beginning. It can't have existed forever. It had to have a beginning. So everything we observe in our observations of the universe and everything we can predict from the physics that we know and understand gives the same conclusion, that the universe had a beginning. And this has extremely profound theological implications. If the universe had the beginning, then whatever caused the universe can't be a part of the universe. If the universe had a beginning, the cause has to be outside of the universe, what we call transcendent. So only worldviews that include a transcendent cause agree with what science has predicted or what science has learned. So there are many worldviews about, if there's a deity. There's a pantheistic worldview that basically the universe itself is kind of God. But the universe came into existence, so that basically rules out pantheism, that the universe itself is God. The universe doesn't appear to be cyclic. It doesn't appear that it's going to expand and collapse and expand and collapse. So worldviews that include cycles like reincarnation seem to be ruled out by what we learn in science. But the worldview that there is a transcendent God who's outside the universe is supported by the things we've learned in science. So if the universe had a beginning, it might have had a beginner. And this is something every scientist recognizes. They don't all agree that there is a beginner, but they will agree in general that it might have had a beginner. And this was understood when the evidence for the Big Bang became overwhelming. Robert Jastrow, who is an agnostic scientist, wrote in 1978, when it was clear that the universe seemed to have a beginning, he wrote this: "For the scientist who has lived by his faith in the power of reason, the story ends like a bad dream. He scaled the mountains of ignorance, he's about to conquer the highest peak, and as he pulls himself over a rock, he's greeted by a band of theologians who've been sitting there for centuries." Right? The theologians that said there is a God. Now, I find this interesting that some of the things that science has learned were actually predicted in the biblical record, the things that are written in the Christian Bible. The first is that the universe had a beginning. We didn't know that until very recently, but the very first statement in the Bible is that the universe had a beginning. In the beginning, God created the heavens and the earth. We also didn't know that the stuff of this universe didn't exist at one time. But the Bible says that the stuff of the universe did not exist. The writer to the Hebrews says, "We understand that the universe was formed at God's command so that what is seen was not made out of what was visible." But maybe the most remarkable statement found that tries to correlate, or that does correlate what we read in the Bible with what science has learned, is the fact that the Creator seems to act outside of time. Paul writes, this grace was given us. Something happened before the beginning of time. Now, out of all the holy books in the world, the Bible, the New Testament, is the only holy book that explicitly says, not implicit, but explicitly says that God acts before the beginning of time. And we didn't even know that time had a beginning to the mid-1970s. But yet the statement is clear that there was a action before time itself had a beginning. So the origin of the universe seems to point to this transcendent creator. Strong evidence that there is something beyond this universe that brought it into existence. The next thing I want to talk about is the design in the universe. And I'm going to focus on something called the anthropic principle. It comes from the Greek word anthropos, which means humanity. And it's the idea that the universe seems appear that it's designed with humans in mind. There's a bunch of parameters, maybe 100 parameters or so, that if they were just changed slightly, either there'd be no universe at all, or a universe that's inhospitable to life. Think of it as like a control panel with 100 knobs, and these knobs control things like the mass of a proton or the speed of light. And if you're to change the knob just a little bit one way or another, you would either have no universe or a universe that's inhospitable to life. One of the classic books on this, it's really old, but it's still very relevant, is this thing, the book, The Anthropic Cosmological Principle, which lists maybe 100 such parameters. So let me just give you a few ideas of what we mean when we say these parameters are finely tuned. We don't have all night, so I'm not going to give you 100, and I don't want to put you to sleep. Might be fun. But anyway, all right. So here's what will be on the quiz at the end. You need to know that atoms are made of nuclei, nuclei are made of neutrons and protons, and neutrons are made of quarks. And it's this force called the strong force, which binds quarks together in the neutron and proton and binds neutrons and protons together in the nucleus. This is what I've spent about 30 years of my career studying, is this strong force. It's because of the strength of the strong force, the exact strength, that we have the periodic table. So if you don't like chemistry and you don't like the periodic table, you can blame the strong force for that. So what if I was to take the knob that controlled the strength of the strong force and change it just a little bit? Let's say I was to make it 2% stronger. What would happen to the periodic table? It would basically get rid of hydrogen. If the strong force were 2% stronger, there would be very little or no hydrogen in the universe. So that's a problem, right? What is water? H2O, there'd be no water. What is our sun burn? Our sun burns nuclear fuel, which is hydrogen. There'd be no stars like our sun. What if you were to take that strong force and make it 5% weaker? Well, then this is what the periodic table would look like. There'd basically only be hydrogen. So chemistry class will be really easy, right? We're going to study hydrogen today, but it's not very good for life. Another thing that seems finely tuned is how carbon is produced. So in the Big Bang, there was only hydrogen and helium produced. So where does carbon come from? All of life is based on carbon. Your DNA is a long string of carbon atoms with other things attached to it. All of life is carbon-based. Where did that carbon come from? It came from dying stars. Stars have a lifetime. They're born, they live for a while, and they die. And one of the things that some stars do when they die is create carbon. And the carbon in your body then is the product of stars that died. It's very poetic in some sense. We are all made of stardust, and that's really a true statement. But the production of carbon as stars die is very complicated. It requires a whole bunch of things called nuclear resonance states. It's a complex process that requires very much fine-tuning. And we find that if you change anything just a little bit, there is no carbon, there is no life. Some researchers in Germany at the University of North Carolina State recognize this. He says, Dean Lee says, we find that more than a 2 or 3% change in the light quark mass, so let me tell you what that means. The light quarks are the quarks that make up neutrons and protons. They're called up and down quarks or light quarks. And what he's saying is if you change that mass of those particles that make up every neutron and proton in your body, if you change that mass by just 2 or 3%, it would lead to problems with the abundance of either carbon or oxygen in the universe. We wouldn't be here. There'd either be not the right amount of carbon or not the right amount of oxygen, depending on how you change the mass. One more parameter, just to give you a feeling for this, is called the entropy of the universe. So the entropy in kind of a colloquial manner or colloquial definition is how much things are disordered. And so, as things get more disordered, entropy increases. And there's a law of physics that says entropy will always increase. So that means that the Big Bang itself was not a chaotic explosion. It was a well-defined, well-formed, well-organized beginning of the universe. The entropy of our universe when it started, the order, was extremely low. In fact, Roger Penrose has calculated that the initial entropy of our universe is fine-tuned to 1 part in the 10th, to the 10th, raised to the 123rd power. Just a remarkably small number. And we have very few ideas as to how that could happen. It seems to be very fine-tuned. So there are a lot of things that seem to be fine-tuned in the universe. I've mentioned 3 of them: the strong force, the formation of carbon, and the entropy. But there's 100 or so of these things, depending on exactly how you calculate them. In their book, Cosmic Coincidences, John Gribben and Martin Rees write this: if we modify the value of one of the fundamental constants, something invariably goes wrong, leading to a universe that is inhospitable to life as we know it. When we adjust a second constant in an attempt to fix the problems, the result generally is to create 3 new problems for every one that we solve. The conditions in our universe really do seem to be uniquely suitable for life forms like ourselves, and perhaps even for any form of organic complexity. It looks like the universe is designed. It looks like the universe is designed. So that's the origin of the universe, that's design in the universe. Let me talk a little bit about what's called the rare earth hypothesis. And the question we're trying to ask here, we're trying to answer, is what's the requirement to have a planet that can support higher life forms? And by higher life forms, I mean anything more complex than bacteria. Bacteria can live almost anywhere. There's extremophiles that live in super hot, super cold climates. But anything more complex than bacteria, it's harder to find a planet that could support that kind of life. Now, of course, we know from watching Star Wars or Star Trek, whichever is your favorite, that life like us is all over the universe. But we can really ask the question, is that possible? So what do you need to have a planet that can support higher life forms? First of all, you need to be in a spiral galaxy. About 10% of the galaxies in the universe are spirals. This is what our Milky Way galaxy would look like if you could get far enough away from it. And these, rings of what looks like clouds are 100 trillion stars in this spiral shape. And only spiral galaxies can probably support complex life. The other kinds of galaxies are called irregular galaxies and elliptical galaxies, and they have problems with the amount of radiation, with the rate of star formation, and other things that make it highly unlikely to have life. But you can't live anywhere in the galaxy. If you're too close to the center, there's too much radiation, and in the very center there's a black hole. Not a good place to live. Unless you're in the movie Interstellar, then I guess it's okay. And if you're too far from the center, then there's not enough star formation to create the carbon and oxygen and nitrogen you need. So you have to be about somewhere between 1/3 and 2/3 of the way out. That's called the galactic habitable zone. And of course, our sun happens to be right in the perfect spot in the galactic habitable zone. The sun is an amazing star. It's called a class G star. It's one of the few kinds of stars that burn long enough and stable enough to support a planet like the Earth. If you've been camping and you have a fire sometimes, the fire will get too hot, so you have to move away, and then the fire will get too cold, so you move closer. And some stars burn like that. So they don't have a region where the planet is in a nice stable orbit with a consistent temperature. Our sun is a class G star, which burns long enough and stable enough for a planet like the Earth. It's a bachelor star. There's no other stars that surround it. Many stars are binary stars. They orbit each other, 2 stars, and the gravity from one star would perturb planets' orbits in the other star. So there's so many reasons. Our sun's a 3rd generation star, which is the first generation of stars that can actually support a planet like the Earth. So the first generation of stars were only made of hydrogen and helium after the Big Bang. Those lived a lifetime, they died, they spewed their material as they died into the cosmos. That material formed a 2nd generation of stars. But that 2nd generation didn't have enough hydrogen and helium and silicon to make planets like the Earth. Some of those died and spewed their debris into the cosmos, and that debris from the 2nd generation is what coalesced into our sun and our solar system. And it's the shortest amount of time it could take to make a planet like the Earth, the 9 billion years that it took to create our solar system. The Earth is unlike any planet we know. There's so many parameters that are just right for life. If we were to change its distance from the sun by about 2%, it would disrupt the water cycle on our Earth. You can't change much how fast it rotates. If it rotated faster, winds would be too great. If it rotated slower, there would not be a good temperature differential. Even tectonic activity, which causes earthquakes, is required if you want to have life on a planet. In their book, Rare Earth, Peter Ward and Donald Brownlee say that tectonic activity may be the single most important reason why we still have water on the Earth. So if you ask if there's a God who cares about people, why do we have earthquakes? Which is the result of tectonic activity. Without earthquakes, we wouldn't be here. Without earthquakes, the water on the Earth would have evaporated long ago. And so earthquakes are required if we are to be here. The moon plays an important role. It's the single large moon that stabilizes the tilt of the earth, produces tides. Jupiter plays a large role. It's this huge planet that has a huge gravitational field, so it acts like a vacuum, sucking up comets and things like that, asteroids that would hit the earth, but Jupiter instead takes the brunt of the impact. In their book, Rare Earth, which I just quoted, Peter Ward and Donald Brownlee say this: if some godlike being could be given the opportunity to plan a sequence of events with the express purpose of duplicating our Garden of Eden, that is the earth, that power to face a formidable task, it is unlikely that Earth could ever be truly duplicated. Right? So it seems to be a rare, if not unique, planet. Finally, I just want to very briefly talk about the fact that mathematics describes the universe. So you guys all know these equations, I'm sure. The first one is the equation for the standard model of particle physics. It's what describes the particles in the universe and the forces in the universe. The second one is the equation for general relativity that describes gravity. These equations describe our universe. And it's quite remarkable that math describes the universe. It looks like it's designed. In fact, physicists will say we don't even understand something until we can write an equation that describes it. But who else writes equations that describes things? Engineers do this all the time. If you want to build a bridge or an airplane, you first write the equations that describe how to do it. And it's quite remarkable that our universe, the language of the universe, is described by mathematics, as if there is a mind or a designer behind it. In his famous article, Eugene Wigner writes this about mathematics: the miracle of the appropriateness of the language of mathematics for the formulation of the laws of physics is a wonderful gift which we neither understand nor deserve. Mathematics describing the universe looks like there is an engineer, a designer behind it all. But that's not the whole story, because math only describes the universe. It doesn't create the universe. And scientists wonder then, how much farther can we go? Is math enough? Stephen Hawking, in A Brief History of Time, writes this: even if there's only one possible unified theory, even if we understood all the math, it is just a set of rules and equations. What is it that breathes fire into the equations and makes a universe for them to describe? The usual approach of science, of constructing a mathematical model, cannot answer the questions of why there should be a universe for the model to describe. Why does the universe go to all the bother of existing? The equations are great, they describe the universe, but they don't build the building. You still need someone with enough power and enough insight and enough resources to build the building. And we've got the universe. So all of this evidence combined makes scientists write things like this. Fred Hoyle writes, a common sense interpretation of the facts, I like that, suggests that a super intellect has monkeyed with physics as well as with chemistry and biology, and that there are no blind forces we're speaking about in nature. The numbers one calculates from the facts seem to me so overwhelming as to put this conclusion almost beyond question. Fred Hoyle is an atheist, but he says when you look at the facts, it seems like there is a super intellect who's monkeyed with physics and biology and chemistry. Right? This is quite remarkable evidence for some kind of deity. I don't know if you know the story of Antony Flew. Antony Flew was one of the premier atheists of the 20th century. He spent his life dedicated to promoting the worldview of atheism. And when he was 81, he changed his mind and became a theist, never following any certain religion, but believing there was a God. Can you imagine spending your whole life defending a worldview, and at the end admitting that you were wrong because the evidence is so overwhelming? And at 81, he says this: I now believe that the universe was brought into existence by an infinite intelligence. I believe that this universe's intricate laws manifest what scientists have called the mind of God. This is the world picture as I see it that has emerged. Where? From religion? From holy books? No, from modern science. Science gives us a great evidence that there is such a God. Now, I could stop there, but I want to be honest with you, because this evidence has been around for a long time. The Big Bang origin started in the 30s. It says the universe had a transcendent origin. The anthropic principle started in the 60s. It says the universe appears designed. The rare earth hypothesis started in the 90s that says our Earth seems rare. And as I've given these kinds of talks for over 20 years, the evidence keeps getting stronger. Any good scientific theory, the more you learn, the stronger the evidence becomes. And that's been the case with the things about science and God. But because people like myself and others have been promoting this idea for so long that modern science gives evidence for God, there's been kind of a backlash. And over the last 10 to 15 years, there's been a number of books that have tried to refute this evidence. Since I'm a scientist and someone who believes there's a God, I want to know what truth is. So how do I determine truth? By reading the best arguments on different sides of an issue. So I read a number of books by people who I don't agree with. In fact, this is one I just finished, great book by Sean Carroll, very articulate atheist. And these books have come up with alternative views. So just in the spirit of trying to discover truth, what I want to do is go through some of the alternative views that people have proposed so that you can see the evidence for yourself. If you don't believe these things point to God, well, what do you say? So the rare earth hypothesis, there are really two ideas. I'm going to give you two ideas for each of the things I've brought up, even though there's more than two, just to give you a flavor for this. And the two ideas that are most popular, either there are lots of planets, so one must be suitable for life, or maybe there are other forms of life. The brief refutation of these is, first of all, there's little possibility of any Earth-like planets forming by chance. And the second one is that all life really has to be carbon-based. So when you read in the newspaper or on your phone that they found an Earth-like planet, what do they mean? They actually mean one of three things. Either the planet is about the same size as Earth. Well, Mercury is about the same size as Earth. It's not Earth-like. Or the planet is orbiting a star in an orbit that is close enough at the right distance from the star that it might have water on it. Well, Mars is such a planet. It's not Earth-like. Or the planet is made of rocks and not gas. Well, Mercury is made of rocks. So when you read they found an Earth-like planet, they have not. In fact, I forget his name, his last name Brown, wrote in an article in the Wall Street Journal, he's an astrophysicist, we have to quit saying we find Earth-like planets, because we haven't. But we can make a calculation of whether or not there are many Earth-like planets. Physicists do this all the time. We call it the back-of-the-envelope calculation, because you can estimate, it's a rough guess, of what you think it would take to find an Earth-like planet. We know you have to be in a spiral galaxy, that's 10% of the galaxies. You know the stars to be the right distance from the center, that's 20% of the stars. You know that the planet has to have tectonic activity. We don't know what planets do. None in our solar system do. So we guess maybe that's a 5%. And this is a partial list of the things you need to have a true Earth-like planet. Here's a more complete list, right? And this list keeps getting updated. I don't have the strength to rewrite it. But this list has 322 parameters. And when you do the math, including correlations and things like that, if you care about statistics, you come up with a probability 1 part in 10 to the 304 of finding an Earth-like planet in the visible universe. The universe is probably bigger than what we can see, but we talk about what we can see. Of course, there are at least 10 to the 22 planets in the visible universe. This still gives a huge or a small probability that there's going to be any Earth-like planet. So it's easy to wave your hands, which scientists do all the time. Stephen Hawking does it in A Brief History of Time. It's easy to wave your hands and say, oh, there must be a lot of planets. And so there must be a lot like the Earth. But you only have to do a quick calculation to realize that there's probably no other planets that can support life. Although there are many planets in the universe, it's unlikely that there are any habitable planets. What about other forms of life? We know from Star Trek that there's the Horta. We've seen that one, which is really a man in a little suit, if that was bad technology back then. But ours are other forms of life. Well, what do you need for life? You need something that can reproduce. You need something that can store information. Carbon is perfect for life because it can create long molecular chains that can store information. Other people have proposed silicon, like the Horta, that maybe silicon could be a foundation for life, but it's not. In their paper on whether silicon could be a form of life, these people write, carbon chemistry is the chemistry of life, silicon chemistry is the chemistry of rocks. When you try to make some kind of life chemistry out of silicon, adding oxygen and other things, you get rocks. There is no other element on the periodic table that can give you life. And since carbon is the only element, we know there are very tight constraints on what kind of environment a carbon life form can live in. And so, yeah, it's great to say, well, there's lots of kinds of life. Well, give me one. What else is it? There are no other options. It's carbon-based life, and that life has strict, very strict requirements that are required. What about the origin of the universe? Well, there's lots of proposals. One is that there was no actual beginning. The other proposal is that the beginning is just caused by the laws of physics. So the brief response to this is there might not have been a beginning, but everything we know about science says there is a beginning. And then the second one is laws are descriptive and still require an explanation. Let me just give you a little more detail on this. So what is definitely true, and every scientist will admit this, is we don't know what happened in the first trillionth of a trillionth of a trillionth of a second of the universe. We don't probably even have a good theory of what might have happened. And so what we can do is we can speculate. And there's lots of speculation. But everything we do know, all the calculations we do know, and all the observations we do know, says that there really was a beginning. So if you want to make an alternative proposal that doesn't have a beginning, it not only has to appeal to a gap in our knowledge, I call it atheism of the gaps. You not only have to appeal to a gap in our knowledge if you want to create a universe without a beginning, but you also have to supersede what we do know. You have to say that in that first 10 to the minus 30 seconds, everything we do know gets thrown out the window with the new physics that I have invented for various purposes. Now that may be true, but most of these none of them satisfy the BGB theorem, most of them don't solve the entropy problem. So what did the author of the BGB theorem say about the beginning? He says, with the proof now in place, cosmologists can no longer hide behind the possibility of a past eternal universe. There is no escape. They have to face the problem of a cosmic beginning. As long as we have things we don't know, you can always speculate that maybe something will supersede what we do know. But what we do know says there's an actual beginning. Could that be caused by the laws of physics? Well, if so, it just pushes the problem back one step. Where did the laws come from? And again, Lincoln understands this. The description of the creation of the universe from nothing is given in terms of the laws of physics. That makes you wonder, where are these laws? If the laws describe the creation of the universe, that suggests that they existed prior to the universe, right? You just pushed the problem back one. The question that nobody has any idea how to address is where these laws come from and why these laws in particular. I would argue there are people who know how to address this. All you have to do is propose a lawgiver, a designer, a creator who made the laws. Finally, what about fine-tuning? Again, there are lots of proposals. One proposal that many of you have heard of is that there are many universes, a multiverse. And if there's many universes with different laws of physics, we would just happen to live in the right one that allows life. And we know there's a multiverse because we watch Marvel movies. I mean, Marvel would not have a franchise anymore if there was no multiverse. Okay, so we know it must exist. Another option is that there just is no fine-tuning. It's all an illusion. So the brief answers to this is, first, there's no evidence for a multiverse, and there are many multiverse models, and most still require fine-tuning. I'll talk about that. And then finally, for those who just say there is no fine-tuning, again, they're appealing to ignorance. Everything we know from physics says there is fine-tuning. So let me just briefly go through this. Suppose a multiverse was discovered. I know many scientists, including scientists who believe in God, that think a multiverse is likely. So if a multiverse was discovered, would that affect the evidence for God, and would that solve the fine-tuning problem? Well, there's really two things to discuss with that. The first is there are many multiverse models. So you can't really make any statements about this until you know which model is right. So first we have to figure out which model is right, and then we can make some statements. But even so, with a multiverse, only a few universes could support life. So we're still in the favored universe. That could just be a selection effect. Finally, it may be true that the laws of physics require a multiverse to have complex life. Suppose the universe is based on string theory. Some of you have heard of that. If string theory is correct, then there might be a multiverse. But if string theory is correct, you might need to make a multiverse, even if you want to make one planet like the Earth. So maybe God's sitting up there and going, I want to make a planet like the Earth. Let's base it on string theory. Oh, to do that, I need to make 10 to the 500 universes to make one planet like the Earth. No big deal. I can do that. So maybe if we find a multiverse, it'll actually strengthen the evidence for God rather than weaken the evidence for God. We just don't know till we find what the right theory is. Again, I know many people who believe in God that think God did make a multiverse. And whether or not we can discover it, who knows? Finally, kind of a philosophical question is, how many universes would an infinite God make? One? That just seems like a waste if you're an infinite God. Right? Finally, there are those who say, well, there's no such thing as fine-tuning. It's kind of an illusion. There's lots of reasons people say that. But these two guys, Luke Barnes and Grant Lewis, are two astrophysicists from Australia. They wrote a book called A Fortunate Universe, and it's a great book because Luke Barnes is a Christian and Grant Lewis is an atheist, and they both agree that fine-tuning is real. Luke Barnes says it's because there's a God. Grant Lewis says it's because there's a multiverse. But they put to rest the idea that there is no fine-tuning. They say this reaction against fine-tuning might stem from the belief that fine-tuning is the invention of a bunch of religious believers who hijack physics to their own ends. This is not the case. The field of fine-tuning began in physics journals and remains with physicists. They go on to say, while there is more work to be done, physics has tended to consolidate our understanding of fine-tuning. The universe really is, or really appears to be fine-tuned. So you take all this evidence together, and what does it point to? I still say, despite all these possible alternatives, and they are possible alternatives, nobody knows for sure which is the right one, but the best explanation, because it solves all the problems, is still that there is a transcendent, intelligent designer and creator who has a purpose for humanity. Now, why do I add the purpose for humanity? Because that's what physics says. Paul Davies, who's an agnostic physicist, says this about the design in the universe. If physics is the product of design, the universe must have a purpose. And the evidence of modern physics suggests strongly to me that the purpose includes us. Right? The first question I ask is, what does modern physics have to say about God and the place of humans in the universe? The agnostic physicist says, the evidence of modern physics suggests strongly to me that the purpose of the universe includes us humans. From physics, not from any religious text. Although religious texts say the same thing. In about 900 BC, King David wrote this, when I consider the heavens, I think it was 900 BC, somewhere around there, the work of your fingers, the moon and the stars which you set in place, what is man that you're mindful of him, the Son of Man that you care for him, right? He said the same thing, when I see the heavens, how can it be that the purpose includes us? But that seems to be what we learn from modern physics. Alan Sandage was an atheistic, agnostic astrophysicist who, as he studied nature, he changed his mind. He became a Christian. He said, it was my science that drove me to the conclusion that the world is much more complicated than science. It is only through the supernatural that I can understand the mystery of existence. And George Greenstein, another astrophysicist, writes this about all the evidence. He says, as we survey all the evidence, the thought insistently arises that some supernatural agency, or rather agency with a capital A, must be involved. Is it possible that suddenly, without intending to, we've stumbled upon scientific proof of the existence of a supreme being? Now, I don't think you can prove God, so George Greenstein is going even farther than me. But this is how strong the evidence is. That atheists, when they're 81, change their mind. That George Greenstein writes, is it possible that this is proof of the existence of a supreme being based on science? And Paul Davies says that the evidence of modern physics suggests that the universe has a purpose, and that purpose includes us. I'll make a much less bold statement. All I will say is that I think the discoveries of modern science give abundant evidence for the existence of God. And the findings suggest not just a deistic God who started and let it go, but this transcendent, intelligent designer who created the universe and has a purpose for humanity, which I find remarkable, or maybe not so remarkable, that that's a perfect agreement with the attributes of God as described in the Bible. Science seems to have stumbled upon some kind of transcendent being with attributes that look very similar to the attributes that we find of God described in the Bible. I've written a lot more on this subject. I have a blog if you're interested here, although I haven't updated it in years because blogs are kind of out of sync today or whatever. I wrote a book on this and other things. And then I'd love for you to be able to ask any questions. No questions are out of bounds. We're looking for the truth. You can ask questions by going to here or scanning this QR code. And I think Kent is going to come up and do a few things while there's a questionnaire to fill out here, which we'd appreciate you do. And while you're doing that and preparing questions, Kent's going to make a few announcements, and then I'll be back up to answer as many questions as you want.
Thanks, Mike.
Yep.
Super interesting, thought-provoking. I'm sure looking forward to the Q&A time and what we ask. You can ask any question you want. Right now, you can stand that right now and start that as we're making these quick announcements. We got 4 sponsors here, 4 different groups of sponsors we spent. We're going to have to share briefly about who they are. And there's also a spot on that comment card if you want to make information on either of these 4. So start filling those out right now. Scan that barcode as we share that right now.
I'm Alan, and I represent Crew, which is a college ministry that is here, that's all about Jesus, getting people plugged into community, and teaching them how to live life on mission. We meet Tuesday nights in the Multicultural Center, usually in the Unity Room, and we also have Bible studies that meet in Knoll Hall on Wednesday nights at 7 o'clock, and also on East Campus on Thursday nights. Those are men's and women's groups.
Hello everyone, I'm Caleb, one of the student officers of Nebraska Christi. We're a Christian ministry here on campus. We discuss philosophical, scientific, and historical reasons for why we believe that Christianity is true. We want to be a place for students to come together and talk about the tough questions that we have about life and about God. We meet every Wednesday night right at Festival Hall in the Heritage Room at 7 o'clock. We'd love to see you there tomorrow night. We're going to be discussing objections to the Bible. So we'd love to see you there tomorrow night at the Heritage Room just right behind us.
Hi, I'm Jacob. I'm with Christian Grad Fellowship. We are a Christian Relations graduate students. We meet every Monday at 7 p.m. for a Bible study. We're studying the first letter of John this semester, and we meet Monday at 7 p.m. and Friday at 1 p.m.
My name is Leanne, and I represent the Christian Faculty Staff Forum group here on campus, which is a group of faculty and staff who meet together to impact the gospel or the campus with the gospel of Christ. We gather together in fellowship to create a supportive environment where faith and academic pursuits intersect. And we seek to engage the University in love and point to Christ and strive to strategically live life glorifying God.
Thanks, guys. Appreciate that. Real quick here, Dr. Strauss would love your feedback too. So if you go to that landing page here, you're going to see the comment card, which is the second option there. The third option is some seminars he's doing. You also probably have a paper underneath your chair of 2 seminars that Dr. Strauss is doing tomorrow here in the Union, in the southeast corner of the first level of the Union. Okay? And so feel free to come to those. One's an open forum, and so you can read all about those there. Now we're going to move into our question and answer time. And we're going to probably rotate back and forth between what's sent in. So the third option, when you scan that landing page you'll land on, the third option is to ask a question. So you can put that in there as well. And we will be going through those from up front here and rotating. So without, I'll hand this off to Alan, and we'll move into the Q&A time.
So just to clarify, you can raise your hand and ask questions, or you can send them through the landing page.
You discussed the beginning of our universe, but yet my question to you is, for every beginning, there's an end. And even in the Bible, Jesus Christ says, I am the Alpha and the Omega, the beginning and the end. My question to you is, what about the end? Will God do something about mankind destroying Earth? I know as a person living in a rural community, climate change and global warming has impacted us tremendously, even here in Nebraska. And so, are there any clues or things that you have noticed as a scientist that maybe the end is coming?
Yeah, so that's a great question. I mean, there's a bunch of ways to answer that. From a cosmological viewpoint, the universe isn't going to last forever. There's this thing called dark energy, which is causing the universe to expand more rapidly. Eventually, the universe is going to die a heat death, In other words, it'll just be a constant temperature and nothing will be able to survive, or it will, dark energy could actually rip apart the fabric of space and time, which sounds like another Marvel movie. But you know, as someone who also believes in the Bible, there is a discussion of God intervening eventually in the history of the world and doing other things in the future. But he also, you know, in the 3rd chapter of Genesis, he gave humans the responsibility to take care of the earth. And I think we should take that responsibility as humans seriously. There's probably no other planets that will support us. I mean, despite Elon Musk's, you know, ideas of going to Mars, which we could maybe set up a colony, it's not a long-term future. This is where we have to live. And if we want our grandchildren to have a planet that's habitable, we need to take care of it now. Yeah.
All right, we got one from online. It says, what would you say is the difference between scientists like yourself and other scientists who still agree with this evidence but are still atheists or about the possibility of a creator?
Yeah, so again, this book that I just read, The Big Picture by Sean Carroll, he is an atheist theoretical physicist who's very thoughtful. And his idea is that science has solved most big problems that humans and questions that humans have had, and that he just thinks that will continue, and that all questions about origins of the universe that can be answered by science will be answered. I heard a debate with him where somebody asked him, so if you had an equation up there that described the universe perfectly, there would still be questions like, why do humans have a sense of morality? And why do humans have a sense of, destiny if that's all there is? And his answer is basically, those questions are not answerable. That's the equation, and that describes it. And that is one possibility, that naturalism is all there is, and it may be true, I don't know, but it's certainly unsatisfying as humans, because it doesn't answer deep questions about morality and about destiny, the kinds of things we really care about. It doesn't answer those questions. So the most thoughtful atheists who agree with this ideas from science but have different conclusions, to me, their conclusions may be true. I'm a seeker of truth, but they don't seem to align with reality. The reality that we really do seem to have a moral fiber to us. We really do seem to have a sense of right and wrong. We really do seem to have a deeper connection and relationship than we would have if we're just a bunch of atoms. So there are answers, but I'm not sure that there are answers that may be scientifically satisfying but not humanly satisfying.
Yeah, so I'm not a physicist, totally above my pay grade. But when I read about, these, the Born-Guth-Blanken theorem, right, I have to rely upon what physicists say about it, because I'm not going to dive into the theorems and the math. And it seems like there's a debate going on among physicists, right? And some physicists, like John Carroll, will say that it doesn't say that the universe had a beginning, and then other physicists say that it does. And so then, in looking at this, I'll read what the physicists say, and then I found that Guth and Blanken have talked about it too. And Guth says that the theorem says that it's specifically talking about inflation, not the eternal universe. And he says that he suspects, I suspect the universe did not have a beginning. It's very likely past eternal, and nobody knows. And Blanken also says, the theorem is talking specifically about inflation. Because I'm wondering how are us non-experts supposed to navigate?
So I've been totally honest with you. So if the place where it might not have a beginning is by inventing new physics in the first 10 to the minus 30 seconds. So this is what Sean Carroll and Guth are saying, is that they believe because we don't have a theory of quantum gravity that these ideas will break down when we get very near the beginning. But the problem there's a couple problems with that. First of all, is there are theories of quantum gravity in which this theorem doesn't break down. So even if Guth is putting his eggs in this basket because he doesn't like a beginning. His theorem really says, it doesn't even say anything about quantum gravity. It says as long as the theorem that is correct to the beginning of time maintains causality, there was an actual beginning. So I'm being just as honest as Sean Carroll and Alan Guth, but the difference is they're putting their hope in what we don't yet know. And they may be right, because we don't know. But what I'm saying is everything we do know, including the BGP theorem, says there's a beginning. So when Guth says there's not, what he is really saying is that's because I think my theory is going to break down in the first 10 to the minus 30 seconds. But there's no requirement that it does. Okay? And that's why Lincoln says you can't get around the beginning. He's assuming it's correct to the beginning because even in theories of quantum gravity, it may be correct. But the truth, again, I don't like people who overstate their case. The truth is nobody knows what happened in the first 10 to the minus 30 seconds. Nobody knows if the laws of physics that we know now hold to the very beginning. All I'm saying is that everything we do know indicates there is a beginning. As long as there are things we don't know, we can always get out of a beginning. So there's always room in our ignorance to postulate something that will override what we do know. Does that help?
Yes, thank you.
Good.
Okay, a lot of the questions being cleared in the forum have stuff to do with the idea of a younger. So it says, are Christians who take a literal view of Genesis 1 in direct contradiction with modern science, or is it a fair view that you basically just disagree with?
So this is what I will talk about at one of the seminars tomorrow, because Christians and non-Christians who have read the Bible or know what the Bible says always ask about this idea of what does the Bible say about the age of the universe. And I don't like the idea that those who take the Bible literal, because that's not a good way to interpret literature. The Bible says that trees will clap their hands, which is clearly a metaphor. So you only take things literal that are supposed to be taken literal. And there's this dichotomy that if you believe the Bible, you take it literal. Well, Paul writes that women should wear head coverings to church because that was a cultural thing. None of the women in today's Western world wear head coverings to church because we understand it's a cultural thing. So it's really a poor question, do you take the Bible literally? The better question is, do you take the Bible seriously within its proper culture and language? And that's the real question, and I will talk about that tomorrow. But the short answer is, yes, I take the Bible very seriously. I take the Bible so seriously that I want to understand what Genesis meant in the original language, which is ancient Hebrew, and the original culture. And I want to, because I don't speak ancient Hebrew, I'm going to go read the very best scholars, not to take it naively literally. That's a terrible way to read literature, to take a naive, literal approach. Instead, you should understand what the author meant. And to do that is much more complex. So I believe that the Bible does not teach that the universe is 6,000 years old. I think that's a poor understanding of the original language and original culture and what it originally says. And I think it's very naive. A much better understanding of the account of creation is that those 6 days of creation are not literal days. In fact, one of the best Hebrew scholars who understands ancient Hebrew, a guy named Gleason Archer, wrote in one of his books that if you understand ancient Hebrew, it's clear that the days of creation are not 24-hour days. But yet so many people read it naively in English and say, oh, they're 24-hour days. So that's what I'll talk about tomorrow. And so I think I take the Bible more seriously and more appropriately than those who read it in English naively and say, oh, the universe is 6,000 years old because it says 6 days. That's like saying that if I use the term, in George Washington's day we fought the Revolutionary War, that the Revolutionary War must have been 24 hours. Right? If I say in George Washington's day the colonists fought the Revolutionary War and you say, oh, you better take that literally, that it was a 24-hour war, then you've misunderstood what I'm saying. And I think those who say that the days of creation are 24 hours are totally misunderstanding what the author wrote. And I can show that in the ancient Hebrew. And so it's a bad question, do you take it literally? The correct question is, do you take it correctly within the original context and language? And when you do, it's not 24-hour days and the universe is not 6,000 years old. Let's be serious about what the Bible says, not just be flippant about what it naively says. I'm pretty passionate about that, can you tell? Yeah.
So regarding that view of the non-literal days of creation, how do you go about interpreting the rest of Genesis, as in like the flood?
So again, I don't like the terminology non-literal. It's implying that literal is correct, and literal may not be correct. Again, if I say the base runner hugged the base, and you take that literally, that he's embracing the base, you've misunderstood it. You're getting it wrong. So let's not use the word literal. Let's say 24-hour days, if those days are 24 hours. So I think that the Genesis is telling us history. I think the first chapter is telling us history. I just don't think that to interpret the days of creation as 24 hours is correct. But if each day is a long period of time, which I believe it is, it's still telling us history. And I think that's what it's doing. I think it's telling us correct history, but to assume those days are 24 hours is, to me, an incorrect understanding of what the author is saying.
So what about the flood?
So that flood is historical. But whether or not it's a worldwide flood is another question. That definitely a flood occurred. There were real people on an ark with real animals. The extent of the flood, you have to understand, again, the language and culture that it was written to try to understand the extent. And then also, you have to look at the geology of the earth, because that should tell us something about the history of the earth. But yeah, there was a flood, and there were a family in a boat, and they had animals in the boat, and we can discuss what the language actually means about that actual story. Good questions. Yes?
All right. Do you take a particular interpretation of quantum mechanics, and do you think the evidence points to determinism or deterministic interpretation?
Nobody understands quantum mechanics. Richard Feynman, a Nobel Prize winner, said that. So if you go to Wikipedia and look up quantum mechanics, there's a long article. If you look up interpretations of quantum mechanics, it's half as long as the article itself on quantum mechanics. So there are many interpretations of quantum mechanics. There's the many worlds interpretation and the Copenhagen interpretation and the hidden variables interpretation. I'm an experimental physicist. Quantum mechanics works. It gives me what I'm going to find in my experiment. I will leave it to the philosophers to determine the interpretation, although there are implications about the universe we live in. Sean Carroll, who I've mentioned a few times, who I respect, takes the many worlds interpretation. He literally thinks that every time a quantum event occurs, there are multiple universes, so that there are millions of copies of him in alternative universes. I find that one not very believable. But we don't have any experimental evidence as to which interpretation is correct. So I don't really know. I do know it works. I do know that quantum mechanics is so predictive that I can do quantum mechanical experiments and they work. It's amazing. The math works.
Before the next question, I'm going to just say real quick. For those of you that have the articles of Dr. Strauss, can you just set them by the back two doors right now so people leaving can grab one? That would be great. And everybody's going to get an article, 2 pages that Dr. Strauss wrote. We'll hand them out at the end, but they'll be sitting there if you leave.
And if you need to leave, feel free to. We'll go another 10 or 20 minutes for questions, but if you have other things, you're welcome to leave.
And Dr. Strauss is welcome to stay as long as you want and chat and ask questions personally as well.
Yeah.
I'm a physicist and I'm a believer, but I'm not familiar with the BBG theorem that we talked about. So how does it handle the possibility of when you solve Einstein's field equations, you can have an oscillatory solution? So some people say, oh, we might be close to a saddle point. Maybe that's why we see the universe accelerating, but we might go to a point where it deaccelerates, and then we go to what is called a big crunch. So how does that, the
Yeah. Well, so the BGB theorem talks about the past of the universe, right? So the past of the universe says that as long as you have a universe that's expanding on average, you had to have a beginning. It's not technically a classical theorem, but it does require causality back to the beginning. But it doesn't tell us about the future, whether we're going to have a big crunch or not. But I think dark energy does, right? Unless dark energy changes its sign, the universe is going to continue accelerating. So for those who want to have an oscillating universe, I was once talking to a physicist who his philosophy is that we live in an oscillating universe. And I asked him, well, what about the dark energy? And he says, well, it's going to change sign. But there's no evidence that whatever dark energy is, a cosmological constant or whatever, that's causing the universe to accelerate faster is somehow going to change sign and cause it to collapse. So what I would argue, again, as an experimental physicist, that all the evidence we have is that this universe doesn't have enough gravitational attraction to collapse and has no mechanism for collapse, and every mechanism we do know is a continual expansion. So I don't see, again, as long as there are things we don't know, you can create a model that gives you whatever you want. But everything we do know indicates we had a beginning and we're going to have an end, either a heat death or a ripping apart of space-time. So, but again, nobody knows. There's a famous, I think it's a Danish saying, it's very hard to make predictions, particularly about the future. Right. Good, I'm glad you get it. Yeah. All right.
So the Earth is rare. What makes humans special compared to other Earth life forms? Is there evidence which places humans more central to the universe's purpose than other forms?
Yeah, that's a good question. I think there is evidence for human uniqueness and speciality, if that's a word. I think, this is debated whether humans are unique in any way or whether we're just a higher life form. But, I think there are things that we can point to in the archaeological record, in the historical record. I think the sense of right and wrong. A lion, doesn't ponder whether they kill the antelope in a humane way or not. There's not a sense of right or wrong. I think our morality sets us apart. I think our consciousness sets us apart. We're, the only species we know of. You can never get inside any other species or any other person's head, but our own sense of self-awareness seems to set us apart in a unique way from other creatures. I think our sense of using abstract symbols, although, again, you can teach animals to do some kind of crude art. We use abstract symbols, which seems to indicate an abstract thinking ability. So I think there are things that seem to indicate humans are different in not just quantity, but quality from all the other creatures on the earth. And again, the biblical view is that is the case, that God made humans in the image of God, and that separates us from other creatures. And again, theologians have debated exactly what that means, but I think some of the things I said are unique to humanity. There's, a bunch on this side, or a few on this side.
Hello.
Hi.
So I'm a pretty simple guy. I have a pretty simple question. I think anyone here with any, understanding of probability should understand this question. So this, I believe, kind of breaks down many of your points that you brought up, particularly your anthropic principle and the rare earth theory. So you stated through that long probability analysis that 1 in every 10 to the 282 universes would you see an Earth-like planet appear just by chance. But to that, I'd say, you exist as flesh and bones and some conglomerate of pulp, and through that, you're actually able to ask that question and perform that analysis. And in order for you to perform that analysis, there needed to have been that 1 in 10 to the 282 Earth-like planet forming. So an analogy I draw to that is, what's the probability of there being a coin given that the coin flips heads or something like that? So what's the probability of you, the observer, observing that probability of 10 to the 282 given that you exist? For that, I say the probability is 100%.
Well, that's called the weak anthropic principle. The weak anthropic principle says, of course, that we're here, and so, the probabilities all line up. But that's also what's called the firing squad fallacy. And so it's been thought of in philosophy circles a lot, right? It's the idea that, there's a firing squad of 50 people and they all shoot and the person sitting there is still alive. And he goes, well, of course I wouldn't know that I'm alive if they all missed me. But then you have to ask, well, why did the 50 people in the firing squad miss me? And so it's a known fallacy, that question, the firing squad fallacy. So yeah, it's true, the weak anthropic principle says if I wasn't here, I couldn't ask the question. But it's a fallacy to say, therefore, the probability is high that I should be here, necessarily. You have to look at other factors, like in the firing squad fallacy, that there were 50 people who shot. Now, there is only one universe. So what do? Well, we have to run computer simulations of if we were to change things, what would the universe look like. And what you find out, this is what Geraint Lewis and Luke Barnes do in their book, is if you change anything, you don't have a universe inhospitable to life. I mean, you can still make that claim. There are some philosophical problems, like the firing squad fallacy, that say, well, if I wasn't here to ask the question, then I couldn't ask the question. But I think it's, naive is probably too strong a word, but it's to end there is not really thinking through the fact that you are here. Now again, the firing squad fallacy is not totally applicable because in that case there were 50 people that shot. We don't know how many universes there are. We don't know how this one necessarily came about. But I don't think you can just stop. In fact, in their book, The Anthropic Cosmological Principle, Barrow and Tipler talk about this weak anthropic principle. And in their mind, it's not enough. You have to keep asking other questions. So you can stop there. I think people like Sean Lewis would be happy stopping there. I'm not sure that I'm happy stopping there.
Thank you. All right. Is there any scientific evidence that the intelligent designer has the attributes traditionally attributed to the Abrahamic God, such as all-knowing, all-powerful, and especially perfectly good? And why did you personally decide on the Christian God as opposed to other theistic explanations?
Yeah, I mean, from science you can learn certain things about the Creator. I think I've said some of those. He's transcendent, he's intelligent, he seems to care for humanity. If humans have a moral aspect to them, then he's a moral God because the atoms I'm made of don't have morality. But, so you come with an idea of a deity that has characteristics that are consistent with the Abrahamic God. I don't know that you can come to a complete understanding just by science. The reason I'm a Christian is multiple-fold. First of all, different religions of the world contradict each other. So I am a person that believes in logic. I believe if two things contradict, they both can't be true. So if you look at what Allah is like in Islam, Allah is different than the Abrahamic God. Allah only loves those who love him. The Abrahamic God, the Christian God, loves everyone. And so God either only loves those who love him, or he loves everyone. In Hindu religion, you're reincarnated. In Christianity, you die once. Either you're reincarnated or you die once. You can't be both. And so as soon as you have contradictions, you say either this one is true or they're both false. And when you compare the religions of the world, that's the first conclusion it's easy to come to. Either they're all false or one of them is true. So why would I choose Christianity? Well, the main reason is because the evidence of Christianity, I believe, is true. The main evidence of Christianity is, did Jesus of Nazareth rise from the dead? That is a historical question. It can be addressed just like other historical questions. And I know many people who are historians, who are investigative journalists, etc., who have investigated that question, even going to that question with the express purpose of showing that it was not true, that Jesus did not rise from the dead, and have changed their mind because of the evidence. So the first and foremost reason I'm a Christian is because I firmly believe that the historical evidence affirms that this person, Jesus of Nazareth, rose from the dead, and therefore he is who he claimed to be. He has the words of eternal life. I also think that the Christian worldview is most in agreement with the reality of the world. The Christian worldview explains why humans can be so anthropic at times, so selfless at times, and so evil at times because we are made in the image of God, but we are fallen creatures. We have the image of God within us, the ability to do remarkable things for others, but we also are fallen, so we can invade countries for no reason and we can torture people for no reason. To me, there are many things about the human experience that are best explained by the Christian worldview. But ultimately, one of the early promoters of Christianity, the Apostle Paul said, if Christ did not rise from the dead, if that event is not true, then we are to be pitied and we are fools and we shall all go home. The go home is my words, not his. Right? But that's why I'm ultimately a Christian, because I think the evidence that Jesus rose from the dead is irrefutable, is overwhelming, if not irrefutable. Yeah, there's a question over there and up here too.
I know this is getting outside of your wheelhouse, but you said something there that piqued my interest. I'm studying theology right now. When you talk about, you said near irrefutable evidence that Jesus Christ rose from the dead, like from a historical perspective. What evidence is there? Just like, I'm not aware of it.
Yeah, I mean, the premier scholar on this is a guy named Gary Habermas, who's written thousands of volumes, so you can look up his. I think there's at least 7 or 8 things that all historians tend to agree with. One is that Jesus was a real person who was crucified by the Romans in the first century. The second is that his followers made the claim shortly after he died that he had risen from the dead and that they saw him. And so I think, again, I could go through, I have a whole talk on why a scientist would believe in the resurrection. But I'll tell you another weird one, is who were the first believers in Jesus? They were a bunch of Jewish people who worshiped on Saturday. And by early in the first century, they were worshiping on Sunday. Could you get a bunch of Muslims to change their day of worship from Friday to Thursday? Could you get a bunch of Jewish people to change their day of worship? Remember the Sabbath and keep it holy. It's one of the 10 commandments. Yet for some reason, by early first century, they're all worshiping on Sunday. They truly believed, these people, that something happened on Sunday that was so amazing that they're going to change their day of worship, these devout Jewish believers. And so, to me, there's historical evidence, there's evidence that comes to us today because Christians worship on Sunday. But Gary Habermas is an expert historian on this, and he writes a lot more than I do. But we can talk more about it. Again, when I talk to historians who don't believe in things like the resurrection, they say, well, historians can never affirm a miracle. And I agree with that. You can't affirm anything in the past. But what I say as a scientist is when I have different hypotheses as to what happened, I ask myself which hypothesis best explains all the evidence. My graduate students will bring me a bunch of plots that they've made. And I'll notice that the plots are irreconcilable. This one differs from this one. And they think because their code ran, the plot is right. And I will say, no, if you don't explain all the data, your plots are wrong. And so I do firmly believe that if you ask what best explains the historical rise of Christianity in the first century, in the culture and language and location that it arose, I do believe that the best explanation is that Jesus actually rose from the dead. Let's do this one and one up here, and then we'll stop because we're just about 9:30. And I'll be hanging around if you have other questions. So 2 more.
This says, do you affirm intelligent design theory? I think pointing to the work of Stephen Myers.
Right. I believe there's intelligent designer. There is an organization in Washington, what's the name of it, right? Discovery Institute that has a whole well-developed theory they call intelligent design. I think their conclusions are more or less correct, that what we see in nature points to an intelligent designer. I have a little bit of problems with some of their methodology and some of their terminology, but I won't go into detail. We can talk about that more in private. I think they've done some good work in design theory. Steve Myers has written, and Dembski have written some really good stuff that I think has some validity, but I don't agree with everything they do or all their terminology. And last question over here.
First off, thank you for coming and speaking.
You're welcome.
Appreciate it. But also, I guess, as somebody interested in better understanding the fine-tuning argument, and doesn't understand a whole lot about how physics works and all of this, the habitable zone that you were talking about within a galaxy, that like range in which planets like Earth could possibly exist, if the universe is expanding and the galaxies are expanding, so does that zone change with the expansion?
Yeah, so that's a good question. So the universe is expanding in total. Right now, things that are relatively close together, including galaxies, gravity has more effect than the expansion of space-time fabric of the universe. So suppose, I lived on a big sheet of rubber and we were pulling the rubber apart, it's expanding, but you and I had a rope that was holding each other. Even as the universe expands underneath us, we kind of stay the same distance because the short-term effect of our gravity is stronger than the long-term effect of the rubber pulling out underneath us. That's kind of what's going on with the galaxies, is that the gravitational effect at this point in the universe is stronger locally within like a galaxy than the fabric of space-time expanding. So at this time, you don't see that expansion in that habitable zone. There'll come a time, trillions and trillions of years in the future, when the answer to that question will change. All right, so Kent, you want to close us? Thank you so much for your attention and for coming.
Dr. Strauss.